Alright, in this video we're going to look at the quadratic formula. So you may have already looked at the quadratic formula with your homework tasks, but in class we're going to just focus on the discriminant and drawing graphs from the quadratic formula. So in this video we're just focusing on what the discriminant is. Okay, if you ever want to know where the quadratic formula has come from, here is all the working out done for you. So basically it's taken the general quadratic in expanded form and then solved for x, okay? So that's basically how you get your quadratic formula. You use the null factor law, let it equal 0, and then it's just a bunch of solving until you get x. Now, I think that's quite interesting, but if it interests you, you can read it a little bit more. But let's move on to the key ideas. So here's your quadratic formula. So you can see you've got two. It's not really two formulas. It's basically the same thing. We've just got a minus here and a plus here. And I'll explain later how you only use the one formula, because there's no point in doing everything the same. Pretty much the only thing that's different is the minus and the plus sign. And then you deal with that at the end instead of dealing with it from the very beginning. So that's your quadratic formula. But as I said before, we're just focusing on the discriminant. So your discriminant, and if I just hover over here, it might give us the definition. There we go. Okay, so, well, that doesn't make much sense anyway. I'll explain it to you. So here's our discriminant. Our discriminant tells us how many x-intercepts the quadratic has. So remember, your quadratic could have no x-intercepts, one x-intercept, or two x-intercepts. So your discriminant can tell you how many x-intercepts you actually have in your quadratic, given that it's in expanded form. So by expanded form, if we just go up, we'll just use this table, you can see all three quadratics here are in expanded form. Okay, so the discriminant, we use this little triangle, okay, is equal to b squared minus 4ac. And this part has come from underneath the square root sign. So you can see b squared minus 4ac is your discriminant, and that's also what is underneath the square root sign. And that's because you can take the square root of a positive number, and when you take the square root of a positive number, you get two solutions. So I might just quickly show you that. So if we were to take the square root of 4, you can get positive or negative 2. Okay, so you can get two solutions there. If we were to take the square root of 0, okay, you get, well, let's say we had something before it. So let's say we had 1 plus the square root of 0 is just 1, okay, because this component here is just equal to 0. Okay, so we still basically have one solution, okay, but just because it's 0, we don't have the 2 that we have here, because the square root of 0 doesn't give you positive 0 and negative 0, it just gives you 0. So we have one solution. And then the other one is the square root of a negative number. So let's say negative 4, just to stick with the theme of negatives. Now we can't take the square root of a negative number and get a real solution. So we can't do this. So we say, and you might see this on your calculator, no real solutions. What it means by real is that we can also have imaginary numbers. So if you go on to do specialist maths, you'll be introduced to imaginary numbers, and that's the concept of taking the square root of a negative number. But we just deal with real solutions. So when there's no real solutions, you have no x-intercepts. And that's basically what it's saying down here. So when your discriminant is less than 0, so the quadratic equation has 0 real solutions. Okay, so no real solutions. When your discriminant is equal to 0, we have one real solution, so that's what I did here. And then when your discriminant is positive or greater than 0, we have two real solutions. So you can see your if you have one real solution, that's just what you need to do. And if you have two solutions, that's what you need to do. This part here is a lot shorter because under this square root sign, you just get 0. And some of you might think, oh yeah, that makes sense. And others might be thinking, whoa, this is a lot of information and a lot of it's going over my head. So let's have a look at the discriminant worksheet that is part of your class tasks. Okay, so the first one is determine whether the discriminant for the following graphs would be positive, negative, or 0. So here we have, it doesn't matter whether your graph is positive or negative, it's what it's doing on the x-axis. So this one here has one solution. So remember, if it has one solution, your discriminant is equal to 0. Okay, so one solution. Oops, I should have done. Wow, that's not an I. Hold on. Let's just get rid of this. Ah, look at me. Stickler for being correct. Sorry. Okay, so should be SOL apostrophe N. Just to shorten solution, probably would have been quicker just to write it. Okay, so one solution, therefore your discriminant is equal to 0. Here we have two solutions, so one x-intercepts, two x-intercepts. So we say two solutions, therefore your discriminant is greater than 0. So greater than 0 just means it's a positive. So under your square root sign, you have a positive number. And here we have 0 solutions, okay, because nothing is crossing this x-axis, therefore your discriminant is less than 0. So if something's less than 0, it means it's negative, and remember we can't take the square root of a negative number. All right, let's scroll down. So use the discriminant to determine how many x-intercepts we have. Okay, so let's write the discriminant over here. So it's b squared minus 4ac. Actually, I might write a triangle. It's a terrible triangle. My memory sometimes fails me, so let's just double check that I've got that right. B squared minus 4ac, fabulous. Okay, first one. I haven't got much space here, so we'll do question A first. Now, it's a good idea to identify your value of A, your value of B, and your value of C, because then all you're doing is substituting in the values into your discriminant. So your A, number in front of x squared, if there's nothing there, it's the number 1. B is the coefficient of x, which is 4, and C is your constant, in this case, is also 4. So it's just substituting them in. Your discriminant is equal to b squared. Try to put your b, if you square anything, always try to put it in brackets, just because if you get a negative, you don't want to make any mistakes. Okay, so 4 times a, which is 1, and then c is 4. Okay, so 4 squared is 16. 4 times 1 is 4. 4 times 4 is 16, so therefore it's 0. So your discriminant is equal to 0, therefore we have one solution. Okay, let's go and do another one. Okay, I'm going to do, let's do C. So again, identifying A, B, and C. So your value of A is -1, value of B is 4, and C is 2. So your discriminant, I'm going to write it here because when I cleared it before it disappeared. Okay, so b squared. Now I've got negative here, so this is why I always like using brackets. Brackets, like I explained to my year 7s that they're like big hugs. It's probably why I like them. 4 squared is 16. It's just because of this negative. Okay, we don't want to get mixed up with our negatives. So 4 times -1 is -4, times 2 is -8. So effectively we have here 16 minus -8, so 16 plus 8, and we get 24. Therefore we have 2 solutions because it's positive. Yay. Okay, let's do one more. Now, sometimes people get freaked out if they don't see a value there. Something's missing. They think, what's happened to it? but nothing's happened to it. It's just a 0. Okay. Whoops. Am I actually writing down the right one? I said I was doing G and I'm actually doing H. Okay. That's what happens when you talk and you're trying to do things at the same time. Okay, so we're actually doing H. And there's a +0 here as well. No others have a 0. Okay, so we've got 3x squared minus, oh no, we're doing H. 3x squared plus 5x plus 0. Okay, so our discriminant, b squared minus 4ac. So your b is 5, so it's 5 squared. Sorry, I just wanted to double check something. 3 times 0. Okay, so 5 squared is 25. Oh, isn't that lovely when you get a 0 because it makes everything 0. Okay, so you get 25. So therefore, you have 2 solutions. That's supposed to be the N. Okay. You can also do this on your calculator. So I might just quickly pause so I can get the calculator up. All right, I've just realized that your calculator doesn't actually do it for you. So I'm going to give you a quick lesson on how you actually can put formulas into your calculator. And this is extremely valuable heading into methods and even into further maths when you'll be using formulas. Okay, so there's nowhere on your calculator that can do it. So I'm going to just quickly teach you how you can tell your calculator to store the discriminant. So we're going to call it, so if I go define and then I'm going to call it DISC, disc. You could write discriminant, but each time you want to use this formula, you don't want to keep writing discriminant. So I'm just going to write DISC, and A, B, C are the variables we're using in our quadratic. Okay, so define basically tells now the calculator that we're going to give it a formula called disc, and the variables are A, B, and C. Okay, so that is equal to, and this is where we put in our quadratic equation. So b squared minus 4 times A times C. And then when you press enter, it is now stored into your calculator. So when you want to use it again, you can just write disc and see how it's put it in bold. Okay, so it's bold. It's basically because we've stored it. So if you ever have something stored in your calculator, it will put it in bold. Now all you need to do is type the values of A, B, and C. So if we go back to our worksheet, the very first one we had was 1, 4, 4. So get the calculator back up, 1, 4, 4, and you press enter, and it'll give you the discriminant. Okay, you can also do the same thing for the quadratic formula. So if you wanted to, you can go define, and we can call it quadratic, and then we go A, B, C, and whoops, not plus, equals, and then you'd put the quadratic formula in. I actually haven't tried the quadratic formula just yet, but it would be a good idea for you to actually play around with it a bit to see if you can get it to work. So I'm not going to write it there for you, and I know it can be done, but it'd be a nice little challenge for you to see if you can do it. So heading back, oops, not to Word. Oh, I've just opened up Word, sorry. So then you can go on and quickly check what you've done. The only thing is, let's just go back here, just make sure you've actually typed it in correctly, okay, because if you do this wrong, then obviously everything's going to be wrong. All right, then question 3, write down 2 rules in the form y equals ax squared plus bx plus c that have 2 x-intercepts, 1 intercept, and no x-intercept. So when you think about it, your quadratic, sorry, not your quadratic, your discriminant b squared minus 4ac, if you've got 2 x-intercepts, that has to be greater than 0. So what you might do, instead of having that 0 there, is actually give it a value. And I just try to undo that and it wouldn't work. So let's just give it positive 10. And then you can think about, well, what values there can give you 10, or if you prefer, you can just say, well, what will give me a positive number? So obviously your b, or when it's squared, has to be bigger than this. So you don't want to have big values of A and C. Okay, one x-intercept. So again, write your discriminant, and this time you want it to equal 0. So basically whatever you have here has to equal this part here. Okay, so if you had, say, 4 for B, 4 squared, and then that means that this part here would have to equal 16 to make it equal 0. And then for no x-intercepts, let me just write it, b squared minus 4ac, that has to be less than 0, so this has to be negative. So obviously this part here has to be bigger than this part for it to be negative. So play around with some values. Play around with your calculator as well, so you can get that quadratic formula on there. That would be awesome. And maybe a Freddo Frog for anyone who actually does it. That would be fantastic. All right, girls, have a good day. Bye-bye.